So hello Ruud, thanks for joining us and giving us such a very interesting talk at OpenMPCon.
Thank you.
So you're with Oracle, used to be with Sun and just automatically went to Oracle. And you've been traveling around the world speaking to users. So your talk was on whether OpenMP scales or not, and can you give us some advice to the users who would be viewing this video on how to use OpenMP?
Sure. As I explained in my talk, there's a couple of basic rules to follow. And the biggest one is probably to not use shared data unless you really have to. So avoid shared data as much as you can. Only share when you have to, because there's also the performance risks that you have when you start using shared data. The other big one is try to minimize the number of parallel regions. When you have multiple parallel regions, each time you go through those, you'll get some overhead, and that accumulates. That starts to be noticeable, especially as you add threads. The cost of that will increase as you add threads, so try to put all the work, or as much work as you can, into one parallel region. I think these are the two big things we see as a first level of optimization.
Okay, so then you talked about scalability, and you mentioned how to, you gave some examples,
Right.
How to avoid false sharing. So what happens? Yeah.
Okay. Well, that's a very technical thing. False sharing is very technical. Essentially, what it means is multiple threads try to update the same cache line at the same time. That's a situation you want to avoid. And again, if you think about using private data versus shared data, with private data you don't have that risk because each thread will own its own memory block. So that goes kind of hand in hand with the first advice that I gave. And then you immediately eliminate many false sharing cases. The other thing that I talked about, which is very common, is CC-NUMA. Every multi-socket system these days has a CC-NUMA architecture, and you need to make sure that your data is close to the thread that needs it most, which can be easier said than done. Luckily, OpenMP 4.0 has support for that, so you do have ways of controlling where things run. You still have to pay attention on where will my data go in the memories of these various sockets in my system. So that was the second part of the talk, was about that, data locality. And without that, scalability is not going to be very good.
Another advice you mentioned was to use profiling tools.
Right, yes. Always use a profiling tool. Never assume that you know where the time is spent, because it could be in a very insignificant part of your application that may not be important for your physics or your chemistry problem, but from a computational point of view, it could be very dominant, and you want to make sure that you're optimizing the right part of your application. So always use some sort of profiling tool.
And also you mentioned that often with a little change you can get a big performance improvement.
Often when you know what the problem is, the fix is often not that hard. But of course you need to know what the problem is. That's where the time goes into. So whenever people mention like number of lines of codes and have been changed, as one of the speakers did today, it's not really a meaningful metric. It's about finding the place where things go bad, and that's where you spend the time. That's your time effort. And making the change doesn't take much time to write a couple of lines of code or remove them. So that's the part you need to do. You need to do the homework.
Yeah. Okay, well, that's a nice point to end.
All right. Okay, do the homework. Okay. All right. Thank you.
Thanks. Yeah.
Thanks. All right.